Welcome to the deep dive. Okay, imagine this. You're launching, say, the next big online store. Great products, cool design. But if that site isn't super fast, users are just going to bail on their carts, like faster than you can say checkout.
Yeah.
So today we're diving into something really essential for that. Efficient data handling in Spring Boot. Whether you're a developer just getting your feet wet, maybe prepping for a meeting about system performance, or honestly just curious about how apps stay snappy and smooth, well, this deep dive is for you. We're pulling insights from this really great beginner-friendly guide. It cuts through the technical jargon, makes complex stuff pretty easy to grasp, and just so we're all on the same page, Spring Boot, it's this really powerful, very popular framework, simplifies building Java apps, gives developers a huge head start. Okay, let's unpack this. Our mission today: demystify what efficient data handling actually means, why it's so critical, and importantly, how Spring Boot gives you the tools to nail it, even without being, a seasoned expert.
Yeah, it's funny. It sounds technical, but it's so fundamental. Efficient data handling in Spring Boot, at its heart, it's just about how your application manages data, how it processes it, retrieves it, all to make sure it runs fast,
Yeah.
uses minimal resources, and can handle lots of users without, well, slowing down. Think of it like organizing a really busy kitchen. You want to get meals out quickly, right? Avoid wasting ingredients. That's your resources, and serve a ton of customers smoothly. That's your users.
That kitchen analogy really clicks. So extending that, what kind of kitchen tasks are we talking about in an app? Like reading from a database, calling APIs.
Exactly those things. Reading, writing to databases, calling external services like APIs, even managing user sessions. That's all data handling. And if those aren't efficient, that's when you see the problems. Apps get sluggish. They eat up too much memory or CPU, or worst case, they just crash when traffic spikes.
Right.
And that's where Spring Boot comes in. It offers tools, techniques,
Hmm.
things like caching, better ways to talk to the database, smarter connection management.
So, okay, if I'm new to development, or maybe just someone who uses apps all day, what are the real tangible benefits I'd notice? Faster load times, lower costs.
Oh, absolutely. The benefits are very real. First, apps just feel fast, responsive. That e-commerce site we imagine. Product pages load instantly. Search results pop up right away. Users really expect that now. Second, resource savings. Less memory, less server power needed. That translates directly to lower costs, especially if you're using cloud hosting where you pay for usage.
That cost part is huge, especially for startups.
Definitely. And third, maybe most critically for that growing store, scalability. Efficient handling means your app can support way more users. Thousands, maybe millions logging in at once without the whole thing grinding to a halt. It's really a shift in thinking, moving from just fixing problems when they break to proactively building systems that are, well, inherently resilient and cost-effective right from the start. Efficient data handling is basically the foundation.
Wow, okay. So connecting this to the big picture, it's not just a nice to have, it's pretty much critical for any app that wants to succeed long term. Grow with its users, stay affordable.
Precisely. And for beginners, the great thing is you can focus on adding cool features while Spring Boot takes care of a lot of this efficiency heavy lifting behind the scenes.
Okay, this is where it gets really interesting for me. Spring Boot's built-in features. You mentioned they're beginner friendly. Let's start with caching. What's the deal there? How does that work?
Right, caching. Uh, Basically, it stores data that's used really often. Think product prices, maybe user profiles, popular items on that e-commerce site. It stores it in a super fast place, usually memory. So the app doesn't have to keep going back to a slower source like the main database or some external service every single time it needs that data. It's kind of like keeping your favorite snacks right in your desk drawer instead of running to the store each time.
Ah, the snack drawer analogy, I like it. So for the website, maybe caching the trending products list.
Exactly. Cache that list, and boom, it displays instantly for everyone. No need to hammer the database constantly. It's not just speed, it's like a shield. It protects your core systems from getting overwhelmed by repetitive requests. And Spring Boot makes it pretty easy to set up with tools like EHCache or Redis.
That instant display is key for keeping users engaged. Okay, what about databases? They're often the bottleneck, right? How do we optimize that interaction?
Yeah, databases are a common one. That's where optimized database access comes into play. Spring Boot, using tools like Spring Data JPA, helps simplify and speed this up. What's really neat is you often just define an interface, like a blueprint, and Spring. Well, it automatically creates the common ways to get data for you. Less code for you to write, fewer chances for mistakes. It helps ensure you only fetch the data you actually need right then.
So, like asking the librarian for just the one book you need, not the whole shelf.
Perfect analogy. For that e-commerce login, you just grab the user's name and email, maybe. not their entire order history from day one. It cuts down the database workload massively, keeps things snappy.
And managing connections. Opening and closing connections sounds like it could add up.
Oh, it definitely can. That's connection management. It's about efficiently managing and, crucially, reusing connections to databases or other services,
Mm.
using something called a connection pool. Instead of setting up a new connection every single time someone needs data, you keep a pool of ready-to-go connections. It's like keeping a phone line open for frequent calls instead of redialing every time.
Gotcha. So less dialing, less waiting.
Exactly. Less delay, less resource drain. Keeping a database connection ready for multiple requests on your site is way more efficient than constantly opening and closing it for every little thing.
Okay, this next one sounds intriguing. Lazy initialization. Does that mean we don't have to load everything the second the app starts?
Precisely. That's the beauty of it. Lazy initialization delays creating certain parts of your application. They're often called beans in Spring, just components basically until they're actually needed, instead of loading every single feature, every component right at startup.
Like prepping ingredients only when you're actually about to cook that specific dish.
You got it. It makes the application start faster, and it uses less memory initially because it's not holding on to things it might not even need yet. So that complex admin reporting feature on your e-commerce site, it only gets loaded when an admin actually clicks to view the reports, not when the main customer-facing site starts up.
That makes a ton of sense for startup time. Okay, last one. Batch processing. Sounds like doing things in bulk.
Yep, exactly. Batch processing is about grouping multiple similar tasks together, like saving 100 order updates or importing a big file of new products. You group them into a single operation. Think of it like sending one big delivery truck instead of 100 small vans.
Much more efficient.
Way more efficient. It speeds up the processing significantly and reduces the load on your server or database. Imagine saving 100 product reviews at once versus sending 100 separate database updates. Huge difference for backend performance.
So we've got this amazing toolkit from Spring Boot. Caching, optimized DB access, connection pooling, lazy initialization, batch processing, really powerful stuff. Now, let's really connect the dots. If someone listening is struggling, say, with slow page loads on their site or their database is just constantly overloaded, how do these specific tools solve those common headaches?
Right, let's map solutions to problems. Slow response times. The bane of user experience. That's tackled head-on by caching. Cache those product listings, popular searches. Boom, instant display. No waiting for the database. Then you've got high resource usage. The app's eating too much memory or CPU. That's where lazy initialization and connection pooling really help. Only load what you need when you need it. Reuse those connections. Keeps the app lean.
Okay, so caching for speed, lazy init, and pooling for resource use. What about the database just getting hammered, especially during peak times like a sale?
Yes, database overload, a classic scalability issue. This is where caching and optimized database access work together beautifully. Caching reduces the sheer number of requests hitting the database in the first place. Like caching search results, avoids running the same database query over and over. And optimized access ensures that the queries that do run are as efficient as possible, fetching only necessary data.
Got it. And those painful, slow startup times that frustrate developers.
Lazy initialization is the hero there. If your big e-commerce platform takes forever to start because it's loading every single module, lazy loading keeps the initial startup fast by deferring the loading of non-essential parts, like that admin dashboard we mentioned. And finally, scalability issues the app just can't handle more users. That's where batch processing and caching are key. Batching things like updates reduces database strain, freeing up resources. Caching delivers data quickly without taxing the backend. Both allow the app, like your e-commerce site, to handle those traffic spikes much more gracefully.
It's actually quite elegant when you see how these specific techniques directly solve those really common, really frustrating problems. It makes development less about firefighting and more about building solid foundations. And it really drives home how Spring Boot makes these powerful concepts accessible. You don't need to be a database guru or a concurrency expert from day one. These tools are built in, often simple to enable, like you said, sometimes just adding a single instruction for caching. This has been incredibly insightful, a really solid look at how Spring Boot helps you build apps that are fast, scalable, and don't break the bank on resources. We've covered caching, optimized database access, connection management, lazy initialization, batch processing. Quite the arsenal.
Yeah, and stepping back, mastering this stuff, efficient data handling, it's more than just a technical skill. It's really about building software that's resilient, that focuses on the user,
Yeah.
that can actually handle success, handle growth, handle traffic. It empowers you to build better, more impactful applications, like that e-commerce platform we keep talking about.
That's a great way to put it. But it does raise a question. These tools sound amazing, almost like magic bullets, but are there any, well, any gotchas, things that someone learning this should watch out for when they start implementing them? Any downsides?
That's a really important point. No magic bullets, right? Take caching. It's fantastic for speed, but if you're not careful, you can end up serving stale data, outdated information. So you absolutely need rules, strategies for when to refresh that cache. How often do product prices get updated? How quickly do stock levels need to reflect reality? You have to manage that life cycle.
Ah, okay. So stale data is a risk with caching. What else?
Well, with optimizing database queries, especially using complex features, there's sometimes a temptation to over-optimize. You can end up with queries that are super efficient but almost impossible for another developer or even you 6 months later to understand or maintain. So often the advice is start simple, measure. Optimize where you see bottlenecks. Don't make everything complex right away. Prioritize clarity too.
Good advice. Simplicity first. Anything with lazy initialization.
Yeah, lazy initialization speeds up startup, which is great. But remember, the first time that component is actually requested, there might be a tiny delay while it gets created and loaded. Usually it's negligible, but you probably wouldn't want to lazy load something absolutely critical that needs to respond instantly on its very first use. So it's best for features that aren't on the absolute critical path, maybe like secondary reports or less used utilities, not your main product search function, perhaps.
That's a crucial distinction. So it's about trade-offs. Okay, that gives us a lot to think about. As you, the listener, maybe start your next project, perhaps building that e-commerce site, how might these considerations, stale cache data, query complexity, that initial lazy load delay, how might they influence your design choices? And maybe more broadly, what is the right balance for your specific project between grabbing that immediate efficiency gain versus ensuring your code is easy to maintain and understand in the long run? Something definitely worth mulling over.